These are the notes for the Go in 2.6. In the Go in this section, you'll be asked to solve and justify one-step equations. You've already done some solving of one-step equations, so now we're going to add this layer of justification. The justifications are actually steps that you already know how to do. It's simply that we're going to formalize it with some formal names here. So this first one, you know that when you have an equation, any equation, A equals B, that you can add you can add the same thing to both sides and keep it equal. So add, additive, property of, equal sign, equality. Same thing for multiplying both sides of an equation. So multiplying, multiplication, property of, equal sign, equality. Now this next one the next two have to do with addition. 0 plays a really important role in math in that any number plus 0 is that number. And we have a special name for that called additive identity. I remember this because my identity stays the same regardless of what clothes I put on, whether or not I'm wearing my ball gown or if I'm wearing my overalls for working in the garden. Similarly, this is something that you have done a whole number of times. It's just that we often don't write this step of equaling 0. You know that if you have a number and you add the negative of it, you get 0. We call this the additive inverse. And that inverse means opposite. The next two have to do with multiplication. Again, multiplying by any number by 1, so 1 plays a really important role, keeps the number the same. And so multiplicative identity. Again, it doesn't matter whether or not I'm wearing my ball gown or my work outfit, I am still me. Similarly, you saw this when we solved equations, that I need to do the inverse of x in order to get rid of it, in order to have it equal 1. And so we call this multiplicative inverse. And the inverse of x is the reciprocal. So flipping the fraction. So let's look at two examples. In my first example, I have x minus 8 equals 10. And very often in this justification, you will see them set it up like this lovely table, where on the left-hand side, I show my work, and on the right-hand side, I write the justification. So on the left-hand side, I am going to add 8 to both sides of the equation. And if we look up at the top here, adding the same thing on both sides is this very first property. So we call this additive property of equality. Now, very often in the past, you have just simply simplified right away. What we're actually going to do here is we're going to do an in-between step, which is we're going to actually say this has a special name, the fact that negative 8 and positive 8 cancel. And they cancel by making 0. So I look up here, and up here, the one where the two cancel in addition and make 0 is additive inverse. My last step is that I want the equation to be x equals. So x plus 0 is indeed x. And then I look up here, and again, we have that lovely property that any number plus 0 is the number, and the name for that is additive identity. We have a second example that we are going to do. In this example, the equation is 3x equals negative 18. So again, we have that lovely sort of two-column business happening, where I have On my left-hand side, the equation I'm working on, and on my right-hand side, my justification. So on my left-hand side, I need to undo, inverse, what's happening between the 3 and the x. In number 1, what was happening between the x and the negative 8 was addition. So that was why we used the additive property of equality. In number 2, we have a multiplication happening. So I use the multiplicative property of equality. I then am going to simplify this 3 times 1/3. And again, I'm going to show more steps than I have in the past. So remember that if I multiply a number by its inverse, I get 1. So I've got 1x equals, and then I multiply negative 18 by 1/3. And this step right here where I multiplied 3 by its inverse, a number by its inverse, is called multiplicative inverse. And my last step is to recognize that I'm left with this 1 times x. Remember, 1 plays a really special role in multiplication of numbers. 1 times any number is itself. So I have x equals, and I can simplify negative 18 over 3 to be 6. So again, I multiplied by 1. I kept it the same. I kept it identity, and it's multiplicative identity.